Hi guys, and welcome to Journeyman episode number 15. First of all, I'd like to thank everyone for all the comments that and positive feedback you've left me. I just can't thank you enough. Thank you. On this episode, a little disappointing, it's a fail. What I'm trying to do is fix my my belt sander that I got from Harbor Freight on the flat part here. There's a wobble in the original one. So I tried to fix that, couldn't, so I decided to pour and make another one. As it stands right now, I just have not figured out how to get the wobble now out of this one. It's not the shaft on there. This I did, and I got to figure that out and probably do another episode when I figure it out. I've got some things in my mind that I'm going to try. But right now, something was wrong with my order of operations or something like that that left a wobble in the part that I made. If you want to stick around and see the couple of ways I failed on that, go ahead and stick around and I'll show you what I did there. Well, here are our dimensions for the part. And now our order of operations. First thing we'll do is make a mandrel. And then we'll make a go-no-go gauge, and that's for the center diameter. Make sure it's exactly the same size as on the sander. Then we'll find the center of the part, drill and tap a hole in the center. Then we'll rough turn the center part, and then we'll rough turn the outer diameter in the face. Then we'll flip the part over and face it to final dimension. Then we'll bore a hole in the center to the final dimension, drill and tap that for the set screw, and then strut for the ladies. Because of the size of this thing, work holding is going to be a challenge. What I came up with is to make a mandrel and use a collet to hold it, because I'm going to be cutting on the far exterior. The only thing I could think of was take a boring bar on the outside and run the lathe backwards. So I don't want the chuck to spin off, so I'm going to use a collet. Also, guys, I said this in the last episode, don't wear gloves. That's a safety tip. I should not be wearing gloves, but every now and then I do it, but don't you do it. You can see with a heavy interrupted cut, it sure does vibrate that belt. And now I'm just checking to see how far back I need the thread to fit this thing on there. With the lathe and back gear, I cut a little bit of the thread, then I unlock it, turn it, and then lock it again, and keep on threading. It's turned out pretty good for a cheap little Harbor Freight die on there. Put a little high pressure grease on there, and the threads turned out really beautiful. Because of the irregular shape, I just took and hit some scribe marks at 3 inches several places, and you can see I hit it right in the middle of that. And now I know I'll have my 6-inch circle when I'm done. Well, let's see if that hard work paid off. Come on, baby. Oh, yeah. Oh, this is awesome. Perfect. All right. Would you look at that? It's a thing of beauty. All right, now we can start machining that baby. Since this is going to be an interrupted cut, I got me a piece of high-speed steel and cut it up, actually sharpened it, and it's cutting really well. Yeah. Well, take you bowling? Well, ask your mother, will she take her car to the grocery store, and then I can keep the car with the bowling balls.
Are you coming?
Yes.
Sup?
You'll see several different tools being used in different angles. I'm just experimenting, trying to figure out which tool gives me the best cut and best surface finish. Well, this is the first time I'm going to try this, but run the lathe backwards with this insert upside down and boring bar, because that's the only way I could reach it out here. See if we can get this thing trimmed up. So now it's going to run backwards. There we go. Had to trim this up first of all so I can get the carriage over it, or it was going to interfere. But now that I got this moved back, now I'm going to try to get this. Yes, you guessed it, that different change in sound was the carriage hitting the work. Because the other tool had such an angle on it to be able to cut out, this is the way I can square up the center of it. Well, that wasn't enough, so I'm going to have to take some more off of here. So back in regular forward speed, and I'm going to do some more cutting. Now you can see how close the carriage is to the work. So I have to just reduce the diameter on a lot of it to get it to be able to go under the work. All right, you real machinist, I know. I just didn't think about this in the first place. I didn't know I had a tool that could reach out on the outside and do it and spin it in normal instead of spinning it in reverse. And so I just caught that, and now I'm doing that. And man, when you're turning a big old flat piece of aluminum, it will sing like the Temptations. This is the very first time that I've used this stainless steel to pour the aluminum in. And as you can see, as we get down in here, there's porosity in it. And I can't help but to think that there's some kind of reaction going on with the aluminum in that stainless steel to make it porous. And so far, this is the only time I've ever had porosity is when I use that stainless steel. And here she is, my fail number one. The diameter, I reduced it too much. And also, I just didn't like, you can see that there's some pores in there, and I just didn't like the porosity. And here is all the garbage from, well, not all, but that is a whole bunch of swarf from this thing. So I cut it up and decided to melt it down and do a re-pour. Well, this next pour was a bad pour. I melted down everything and poured it into the mold, and it was not enough. I just didn't put enough aluminum back in. So that was another fail. And so this, what I'm showing right now, is just what it is when I've machined down the part and all that's left over. And basically what it turns out to be is about 3 little ingots is what all that swarf in that pot that I have. Okay, so we've got about 3 if you combine that. 3 ingots, and let's see how much garbage we have. And we have about that much garbage in it. Kind of put a scale, there's my foot. So this is like my 4th pour, and it is big enough, and I'm just hoping that there's no porosity in it.
and I'm taking the lessons learned from the first time on here and trying to apply it to my machining on this time. And I'm still experimenting with cutters, and right here, since I still have using a collet, I'm spinning it in reverse and using a big old ground piece of high-speed steel that's in the holder upside down. I'll explain where this chatter came from later. And this chatter.
Well, I figured out my cutting problem. It just was not cutting with this new plate, and I realized that instead of having this thing all the way against the mandrel, I had it off a little bit and just tightened it up with this. Well, that just wasn't sturdy enough. Once I backed that up and got it onto the mandrel, it's cutting like butter. Okay, now that the cut is uninterrupted again, back to turning it the right way and facing it off. A lot of material to come off. It's coming off pretty quickly and pretty well. Alright, now it's time to get that center shaft to a pretty good diameter. Pull this out of here. That's nice and flat there. Time for it to come off.
Now in my mind, that back flat surface and the back cylinder are square to one another, and I thought that in this 3-jaw that it would get it centered and flat, and it would be relatively flat to the front. For some reason it just didn't work though. Right now I'm just making sure that I do not go past the diameter like I did last time. Measure, measure, measure. Fool me once, shame on you. Fool me twice, shame on me.
That ain't gonna work.
So now I take it off the mandrel and just try to see if I can get things square and flat. Now this little part, I took my time and machined it to be exactly the same size as the spindle on the sander itself. Man, guys on YouTube sure do make things look easy, but when I try it, I sure don't find that easy. Doing what Click Spring does and trying to super glue it onto a mandrel, and had a little bit of a fail there. Luckily, I was able to break that bond and get it off and do a take 2.
Well, this is the first time I'm really turning between centers, so I made up this little mandrel, and I put a set screw in here. Let's see if we can make this thing turn some metal.
Now, it may not be easy to see, but there's just a little bit of wobble on the face of both the front and the back of it, and I'm trying to get everything trued up. And so, tried one side, now I'm going to turn it around and see if I can get the wobble out from the other way. Because of how everything is tight in there and how the tools are, I had to actually do this facing cut with 2 separate operations, one like this, and I had to turn the tool around to face the rest of it.
Well, guys, I always like to share lessons learned. There's a couple things that I did learn just in turning stuff this big. When you're turning things that are 6 inches on a 6-inch lathe, there are some inherent challenges that go with it. I've heard guys on the forums, and I heard guys say this, that using high-speed steel, a sharp high-speed steel ground correctly bit is the way to go. And I'm here to tell you, if you really get a good high-speed steel bit and it's ground well, they do cut so well. So that's something I need to hone my skills on, is how to do that. As far as lessons learned on how to do this, it's got to be something in my order of operations, or the way I implemented it, that gave me the wobble. Hopefully I'll figure that out and come up with a solution to that and show another episode of when I get this fixed. So if you stuck around, guys, I thank you for watching. I hope you enjoyed this, and keep those comments coming if you've got some suggestions for me, guys. Thank you so much for watching. I'll see you on the next episode of Journey to Journeyman.